So today we are going to take a look at pendulums. We're going to take a look at how the length, the angle, and the mass of the bob at the end of the string affects the period of the pendulum. So to do this, we'll do a basic lab where we change one variable at a time and see what the impact is. So I have over here our pendulum system. You can see the mass hanging at the end of the string. That's a 100-gram mass. And so I'm going to start off by setting this mass as 0.1 kilograms. The length of the string, the initial length of the string, when we measure to the middle of the mass, is about 56.7 centimeters, so 0.567 centimeters. We're going to keep this constant through the first three trials of this lab. We're going to change the angle and find out the effect of the period. So I'm going to do a simple 5 degrees, 10 degrees, and 15 degrees, and we will oscillate the mass back and forth 10 times, and we will identify the impact of that on the period. So it's at 0 degrees, I take it back to 5 degrees, and I let it go. It's swinging back and forth, and I'm going to hit start when it gets to one of the sides. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So about 14.96 seconds. Okay, so now I'm going to pull this back to 10 degrees. It's back to 10 degrees. I'm going to let it go. Again, I'm going to hit start on this when it hits one of the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, look at that. 3 thousandths off. I'm not sure that the angle's having much effect. Remember, your finger carries with it 2 tenths of a second of error for starting and stopping. So I take it back to 15 degrees, I'm going to let go. Again, once it hits one of the sides, we'll hit start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I might get a little punchy there, but we'll just go with what's on the screen, 14.73. And so again, 2 tenths of a second error. I'm well within that. Looking at this with 2 tenths on each end, that's 4 tenths of a second of error. These times did not change. The angle had no effect. So the next trial we're going to do is we're going to do the mass of the bob. So we can actually just take one of our trials. I'm going to do 10 degrees, and I'm going to take this and I'm going to stick this in over here because that is going to be one of the trials, 100 grams. So now we're going to do a 200 gram. And again, we will pull it back to 10 degrees. Put back to 10 degrees, and I'm going to release it. And I will reset, and I'll hit start when it hits one of the sides. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 15.25. And now I will do the 500 gram. Again, we'll hold the variables, hold some of the variables constant, which is a good experiment. We're only changing one thing, same length of the string, same angle. The only difference here is going to be the mass. And I will start it when I get to one of the sides. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the times do appear to be getting a little longer here. I think there might be a few reasons for that, but statistically, with 4/10 of a second error, these times have not gone up significantly. I think I would like to do this one more time with these masses to see what happens. My guess is that the string has gained a little bit of stretch to it, and that if I measure the length has changed because of that additional weight on the string. And that did occur. Also, the length of the mass changed, so the center of mass is down here. One of the things we'll talk about in the long run is the fact that we should be measuring from the middle, and so the middle has come down a tiny bit. So this length that we're measuring has actually changed slightly as we did this. So I'm going to go back and make those slight adjustments in the measurement. We can see that it didn't have a drastic change, but with the 500 gram mass, my length is now about 59.8. That's about 3 centimeters more. And with the 200 gram mass, we have a length of about, to the center, a length of about 58.6. And again, this is a 200 gram mass at this point. So you could see here, these are supposed to remain the same. They did change slightly. The change may have affected our overall times. We'll take a look at if length does affect it, and we'll do that now. So we are going to be able to take over one of these values. I'm going to take over the 100 gram value, again, carrying that over and using that in all three trials as one of our values. Paste. There we go. And now I'm going to change the length of this. I'm going to make the length of it a little shorter at first. I have these little loops up here which I can do that with. And so we have a shorter mass. You can sort of see these little loops up here on the stick that we are adjusting it with. And the length of this ends up to be just about 33.3 centimeters. I'll write that one down. Again, we're going to keep the angle and the mass of the bob the same throughout this portion of the lab. And when I pull it back by 10 degrees and I let it go, it starts oscillating. I'm going to start my timer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that time is significantly less. That's a significant change there. And then I'm going to make it a little bit longer. It's almost down to the desk at this point. So we'll take a look down at the desk. And again, I'm going to pull it back 10 degrees. I'm measuring the angle up top using my protractor, and I am going to pull it back exactly 10 degrees. And I'm going to let go of it. And we'll start our timer when it hits one of the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, significantly longer here, 17.81. And we are going to measure the length of this. And the length ends up to be about 78.7 centimeters. I think it's important to note that in the first trial, we changed the angle. In the second set of trials, we changed the mass. And in the last, we changed the length. And we saw no significant difference here. We saw really no significant difference here. We talked about why this was slightly different, and we saw a major difference here. What you're going to do is calculate the period of each oscillation, calculate the theoretical values based on this, and then compare your experimental measurement, which is the measurement from one period. This is your experimental, with the theoretical value, which you got here. So experimental is going to be in green, and theoretical is going to be in red. And then you will use your equation to measure and compare the theoretical and the experimental errors here, as well as calculating the average deviations for both of the sets of trials. So you'll take a look at this set of trials here and compare your experimental periods using average deviation of the mean, and see if there's a significant difference. Do the same with trials 4, 5, and 6. See if there's a significant difference, and the answer should be no. The data is both accurate and precise, and there's no significant difference. And then you will do it with the last one, and there's going to be very little error, but you can't really compare these values because they are not supposed to be the same. They are supposed to be different. The angle does not affect it, the length does not affect it, and the mass does not affect it. The angle doesn't affect it, the mass doesn't affect it, but the length does. And there you go. Give that a shot, and if you have any questions, as always, let me know.